Okay, I don't know if you can hear the background, guys. I'm sorry, there's like music. Okay, so 6.1 slope fields. So slope fields or directional fields will give you some sort of general shape of what the graph is supposed to look like. Okay, so basically they're just teeny tiny slopes of the graph of y, let's say. So they're very small linearizations. They're small linear like slopes depending on where the graph is. So when we sketched the green and orange and blue curves through that point and that point and that point, you can see up here, it looks like this parabolic shape up here. But then when we had to go through 2 comma 0, it's this straight line because there's a bunch of little horizontal slopes. So when you go here and then there's horizontal some more and horizontal and horizontal and horizontal. But when you're doing the orange one, it's horizontal here, but then you can see the slope becomes positive this direction and then it becomes negative this direction. Same thing over here. So up here it looks pretty parabolic, sorry. And then the orange one, if you start here, it goes kind of in this straight line looking thing. And then, oh, there's another straight, and then it just keeps going straight. So it looks like it's linear if you're going through 0 comma negative 2. But if you go 2 comma 0 right here, it's positive and then 0 slope here, and then it's a little bit negative and then more negative. So then it looks something like that. So it looks a little bit different, maybe than even what you have. If yours goes down here a little bit further, that's okay. It's not a big deal. Okay, so it's just a general graph, general shape of the graph. Okay, so that's why we skipped to, did you finish this, by the way? Don't just copy mine. So that's why we skipped to here, and that's why I drew something like that. So I'm just basically saying like, oh, well, this has like general shapes. So it could be like this. It could be like this. We don't really know. This general shape. Oh, this is generally a shape of a cosine graph. It starts up here, and then it goes down and back up. So that's why B was cosine, right? So even though the derivative is negative sine, the original graph was a cosine, and this shows a cosine. So we finished those. The last two, when you plug in some numbers, what you want to do, so the 0 doesn't help you, right? But if you look at this 1, it gives you a slope of 2. So at x equals negative 1, do you have a slope of 2 or do you have a slope of negative 1 for A and G? So if I look at A, at x equals negative 1, I think it was, x equals negative 1, I have a slope of positive, 2 makes sense more than negative 1. So that's why A was number 11. And then if you look here for G, at negative 1, you have negative slopes. And it does look like a negative like fraction. So see how it's a negative. Oh, it's not a fraction, but it does look like a negative slope, okay? So something like that. Okay. Oh, negative 1's here, not here. Just kidding. Okay. So done with this side. Okay, and then we talked about this one. So basically, oh, I want to show you what we did in class. So basically, to graph our slope field, we look at what's given. So only an x is given for this equation of the derivative. So for this equation, I don't need any y values. I can just leave that blank, or from the notes I said it doesn't exist. So then I go ahead and list negative 3 to 3 just to give me a really good estimate of all the numbers. And I plug the negative 3 in, and I get negative 3 minus 1 is negative 4. And everywhere x is negative 3, I have a very, very negative slope. And then I can see I keep doing the same thing. And then let's say I get to 1. Everywhere I have x equals 1, I have a 0 slope. So I draw a bunch of 0 slopes. And then x equals 2, I have a bunch of slopes that are just perfectly positive 1 slope. So perfectly diagonal. And then I draw that all the way down because all my y values are the same. And then I can see, oh, that's a parabolic shape, which makes sense from what we found in B. Because what was B? B was solve for y. How do you solve for y if you have a derivative? You find an antiderivative. Remember that when you're finding antiderivatives, you have to do the parentheses and then you're in terms of x. So you do need that stuff still, okay? And then you find the antiderivative. You have a plus c. This is parabolic because it's an x squared. If they wanted you to solve for x or 1 comma 2, if it said solve for y at 1 comma 2, then you plug 1 and 2 into here for x and y, and you get something like this. You solve for c, and then now you rewrite this whole thing, except instead of a plus c, you have a plus whatever you find for c. After you solve for c here, that's your variable, you just plug it in here. And then that would be a specific equation that would go through that. But if it doesn't ask for it, then, you know, I didn't find it. I just wanted to tell you that usually you do have to do that. Okay, to sketch 1 comma 2, I go here, and then I go to 1 comma 2, and I want to go there, and it looks like a 0 slope. So this is 0, and this is parabolic in shape, and it matches. There you go. Okay, so then you did the same thing for all the left side of the back of the notes. And then you have something like this. So like I did a little with my blue highlighter, I just showed the general shape that could happen. But you have numbers here to prove that you actually did this. You didn't do this in your head. I'm sorry, you can't do it in your head, okay? You have to have numbers here. So here I would only have x's. Here I would only have y's. And then I can figure out what my slope is. I would have x's, figure out what my slope is, and then draw all of those. Notice that when you just have x's, all the verticals are the same, right? So if you look vertically, those are all the same. But when you only have y's, all the horizontals are the same. See how those are all the same? See how these are all the same? These are all the same. And then when you have x and y, when you look horizontally or vertical, they're going to be different. But there's still this pattern. You know how we were doing number 6 and we were trying to find a pattern? It's that same thing. I realized that there was a pattern, but then when I did this one, I was like, oh, this isn't the same thing down here though. So I realized the pattern was a little bit different. There's still a pattern, but it's reflective along this diagonal right here. So, you know, they're all going to look a little bit different, but they're all going to follow some sort of pattern. And you can see right here, there's only a y, so there's no x's. So horizontally, see how those are all the same? Those are all the same. There's only an x. Vertically, those are all the same. Those are all the same. Okay? And then these, I just like plugged in random numbers. It seems like random numbers, but they weren't really random because I did like little bits and pieces and I realized my pattern and I filled in my pattern. Okay? All right, your homework. I said I was going to change it, but I didn't change it because I looked at it and this is pretty quick. So there's just some antiderivatives. All right, so you're going to practice that. You're not actually, your homework doesn't actually have this stuff on it. So we're just doing a little bit of practice before tomorrow, and then we'll have more of the stuff later. Okay? And then obviously you already finished the stuff on the back and you showed your work. If you fake it, that's not smart. Don't fake it. Okay? Do it for real. All right. See ya later.